Hello everyone, welcome, and we have a new circuit here. Transistor amplifier, fixed bias circuit. And this is the circuit. This is our transistor amplifier circuit with a power LED indicator. So we have the transistor here, and let us check the sound. Welcome, and we have a new circuit here, Night Rider. We have here Johnson counter and the LED chaser. That is the sound of the transistor amplifier. We have the cell phone jack and the speaker here. This is 4017. The sound is nice and it is working. Let us see the circuit. This is the Night Rider circuit. We have the 555 timer here. And let's check the circuit. We have here the transistor D882, speaker, capacitor 1 microfarad, a load resistor, base resistor, power on LED, that is the green LED. We have the capacitor 100 nanofarad or 104, and the voltage in here is provided by this cell phone jack or cell phone, or any MP3 player will do. First, we're going to calculate the values of the resistor here. This is a transistor fixed bias circuit. Here, our load resistor RC, we're using arbitrary values. I choose the 1 kilo ohm value. So at saturation, computing for the saturation mode of the transistor using KBL, and that is VCC minus voltage drop at the RC, and then to the VCE, and then to the ground. We know that VC is equal to 0, and then the voltage drop at RC is 12 volts. So using Ohm's law, we find the collector current, voltage divided by resistance, which is 0.012 ampere or 12 milliamps. So we have 1 kilo ohms here, and the collector current is 12 milliamps. Also current flows here, conducting the transistor in saturation mode to turn on the transistor to compute for the base current and the voltage drop across the resistor. Since this is a fixed bias circuit, our transistor is mostly dependent on the current gain. So it is a current gain dependent circuit. So we calculate the base current using current gain formula, IC 0.01 ampere divided by 160, the current gain of the transistor given in the data sheet of this D882 I'm using 160. So we get base current of 0.0000075 ampere, almost equivalent to 75 microamps. Using the Ohm's law, we know the voltage drop here, and we can calculate the voltage drop using the KVL, VCC minus voltage drop RB, and then voltage drop at BE. We get 11.3 volts voltage drop at RB. So we now know the voltage drop at RB, and then base current of 75 microamps. And we got now this value of 150 kilo ohms. I'm rounding up. The actual value is 150, 6666.67, but I use 150 kilo ohms, rounding up. So we get now 1 kilo ohms load resistor and a base resistor of 150 kilo ohms. I'm using this capacitor to bypass the DC and to pass only the alternating current, the AC. Also here, to bypass the DC, and to pass only the AC. So this is the alternating current flowing here to the base, conducting the transistor in saturation mode, amplifying the signal, and we get now here the sound of the amplifier. That is the sound of the transistor amplifier using D882, and we're using this fixed bias sync technique of the transistor. Fixed bias transistor, fixed biasing. This is the circuit, and this is our final circuit. Lots of jumper here, and here is LED power on indicator. This is the night rider circuit. We have the 555 timer here, and the usual configuration. Also, layout here, I'm using the header. I have the header here. This is the header I'm using. At the side, for the power input, voltage input, and the speaker output. That is the header I'm using. This is the transistor here, the capacitor, resistor, LED, header, speaker, capacitor, 104, some resistor here. So this is our circuit, and we are having this transistor amplifier circuit. And thank you for watching. Bye bye.